It's Thursday, and you know what that means? It's Mill Turn Thursday with JitCAD Cam. That being said, Phil Brown here. This week, I'm going to go ahead and we're going to work through a little more of a complex part. This video will be very quick. However, it is also probably going to be a little bit longer as I work through this part. That said, if you guys want a more in-depth kind of review of this, or you want more of a custom experience, feel free to shoot me an email down below, and I'm more than happy to accommodate you guys. That being said, let's go ahead and jump inside this part. So first thing, as always, we're going to be in manufacture, and I'm going to create my setup for turning. Now, it's up to you which way you want to go with this. I always like to actually create my setup and then work backwards from that. So I am going to pick one side or the other. I actually kind of like this side as my first operation. It seems to be a little simpler as well if I'm holding on to this end piece here, being able to get my grooving. So let's go ahead and flip our Z axis. I am going to put my Z off my stock front. And based on my stock size, I'm actually going to go up to like a 6-inch slug of material. And that actually looks pretty good because we have plenty of material on both ends. So we're going to offset from the front. And I'm going to offset it about 50 thou, just in case that saw leaves a really nasty edge or it's a little all over the place. So now that we have our setup completed, the first thing we always do is we go in, we face off our part, right? Let's go ahead and do our turning face. I'm going to use a lot of default tooling here, guys, so bear with me. CNMT right-handed tool. There's my facing procedure. I'm going to do that in multiple passes. And as you can see, we've now knocked out the actual facing very quick and efficiently. So from here, we need to start doing our OD work. So let's go ahead and do our turning profile rough. Again, I'm going to reuse that same exact tool. A couple of things I'm going to do here, though, is we're not going to go all the way to the back of my model. I'm actually going to tell it to go to a selection point, and that selection point is right here at the top of that fillet. And then I'm going to tell it I would like to go past that an extra 100. So we're doing a tangential extension. And as you guys can see, we're now starting at model front and going roughly 100 thou past. Keep in mind, stock to leave and things like that are affecting. We are waterfalling down into these grooves. So let's go ahead and fix that waterfalling by going into our passes tab. So we're not going to allow radial and axial grooving. And with that, you're now seeing that we're making a straight pass across all of those fins. Now, we're going to go ahead and derive this. This is my favorite way to do it. You guys don't have to do it this way, but what a derive allows me to do is to pull those selection points automatically from one path to the other in through Fusion, where I don't have to worry about reselecting or wasting my time and effort. Now, as you can see, we've cleaned up the top part of this. Let's go ahead and knock out our grooves since we're sitting here in this view and we're still thinking turning. Again, I'm going to go to a groove toolpath. I'm going to go into my library. I'm going to go ahead and look for that OD grooving tool. I believe there's one that's a dog bone kind of profile. Now, I like that dog bone kind of profile so that I can either back drag up these walls, but I can unilaterally move, X and Z all at the same time, or I should say X, Y, and Z, depending on your tool and how it's set up. Now, I am going to use rest machining. I do still need to define a back location. So again, this would have been a good time to possibly do, once again, a derive, just to bring some of this through. Lastly, we're going to go to our passes tab. And as you're going to see in your passes tab, you have the availability to change your grooving width for your step overs. Maybe you only want to do down directions. I'm not going to play with a lot of this because, again, I always advise to everybody, let's get the path on the part long before we start modifying things. And as you can see here, and this is a big deal to me, in my opinion, is we are coming in and we are actually going all the way up and down, which, again, we could change that. But we're actually making a finishing pass down this entire part to include the outside of these radiuses. Now, this isn't a big deal. If I had to make 100 of them, this is a big deal because we're wasting time. Same thing would go as when we do our turning profile finish. Are we wasting cycle time? And at the end of the day, we very much could. So if I delete that actual finishing pass and just regenerate my new profile for my turning profile, again, as you're seeing is we're now cut one whole tool path out of the way because the availability and what this tool is capable of. So again, you guys have the ability, like I said, is maybe we only want to go down because we don't have that backside relief, anything and everything. Again, you could actually toggle off your finishing passes here as well and do another tool path as the finishing separate from the grooving. I luck out. This part, I believe, is aluminum, so it's not a big deal. They're actually going to sleeve it. But again, the idea is let's get the paths on the part, and then you guys can tweak it from there. So I'm going to run this through a simulation real quick just to see where we stand on everything. So we'll go ahead and let that do its work. There's our OD rough. There's our grooving path. And then lastly, we're coming back through with that cleanup. And just like that, everything except these ears up here at the top are basically done. So that kind of concludes our OD turning work on a part profile like this. I'm going to go ahead and shift gears and let's knock out milling these ears on the end of this and let's get our drilling done. So I'm going to go in and I'm going to drill first. I'm going to go to a very large 1-inch drill. Again, you always want to fit the biggest drill possible in there if you can. This is something that will save you a ton of time later. So let's go with this 1-inch drill. We're doing some aluminum drilling. I do want to drill all the way down through that bottom reference point. So as you're going to see here, I'm picking that actual face down at the bottom. I'm going to say auto merge, which is going to bring me all the way up to the top. And then lastly, we're going to go ahead and say drill tip through bottom. And then I'm going to give it, probably like an 0.75 breakthrough. We will be flipping this part over or grabbing it with a sub spindle. So we're probably going to drill it again the other way. In this case, if my drill was long enough, I would much rather punch all the way through so that those chips have somewhere to evacuate. So being that you were going to drill it all the way through, keep in mind, guys, you do have that ability to go ahead and say a breakthrough, which is going to slow down so that you're not blowing out your insert. Again, very handy in those exotic metals. But now that we've had that pre-drilled, we could go ahead and do our ID work. So I'm going to go ahead and say turning profile finish. This is going to seem a little redundant to a lot of you, but we're going to go in and we're going to grab our boring bar now. So let's go ahead and do our ID boring. And with that boring tool, again, as I always like to say, guys, hit OK and then come back and fix whatever problems you have. Now, as you can see, it's a little tricky to see inside of here what that tool is doing. So what I'm actually going to do is I am going to do a section analysis, and I'm going to split my part profile in half, making it a lot easier for me to actually see what that boring tool is. So in a lot of cases, I like to start based on my diameters. In my opinion, this is the easiest way to get going on setting things up. So I'm going to go back into my toolpath, and we're going to go to the radii menu. And what I'm going to do is I'm going to change my inner radius to a diameter, and then that diameter is going to be 1 inch because we pre-drilled this with a 1-inch drill. Now, my clearance height, as you guys have seen, I always recommend changing this to inner radius, in my opinion. That way, it's one referencing the other, and then you don't need to do a 400 back off. About 40 is very good. So again, let's go ahead and hit OK and see what we get. We are going too deep, and we're going too deep because of the waterfall effect. So again, we do not need radial or axial grooving. Now, instead of turning off radial and axial grooving, you could limit your depth in your Z direction using the geometry tab. Again, selecting a back face. Now, that's up to you at the end of the day. I'm going to go ahead and just kick on don't allow radial and axial grooving because I know this whole diameter is 1 inch based on our model, and that drill actually achieved that automatically for me. This is not a critical hole. If it was a critical hole, I will chase that with a finishing tool, things of that nature. So now that we have achieved, once again, the ability to go in and rough out our part, let's go ahead and derive into our finishing profile. Again, I'm going to go ahead and hit OK. And you're going to notice that we're stopping short because of that 1-inch diameter versus what our model is. So this is where you can fine tune and tweak a lot of this stuff. So what I'm going to go ahead and do is we're actually going to say my inside radius might be a little smaller than this. So let's go to 995 and see what we get. And now as you're seeing, we're running all the way down to the back side of the part, again, wasting cycle time. So this is where filtering our geometry based on the Z-axis is going to be extremely handy, right? So I'm going to say selected face is this backside. I may want to go past that, 20 thou or so with the tangential extension. And just like that, we're now going to limit how far that finishing cycle comes in and around. So one thing that may be valuable is swapping out that drill to a little smaller drill. This is, again, up to you guys and how you achieve it. Seeing how I have that tool inside the part profile already, for me, it's much easier just to skim it after the fact, and knowing the customer really doesn't care about that whole diameter. Now, one thing I am going to show you here, which is extremely beneficial, is in your passes tab. One of my favorite things in Fusion when it comes to lathe turning is this no dragging. So currently we feed in on the face and then we back off with our tool, right? And if you think about it, we don't have a ton of relief when feeding across our x-axis with this tool. So we could cause chatter, tool deflection, and other problems. What I'm going to do is I'm going to turn on that no dragging, and I'm going to show you guys why it's so beneficial and why I like it. So in this toolpath, if we go ahead and simulate, I'm going to have to kick off my stock. Actually, I won't have to kick off my stock, but if we walk through this slowly, what you're going to see is we're going to do that bore, and then we're going to get to the end, and then we're actually going to pull off of our part, and we're going to move to the inside now of our part, and we're going to feed back out. Again, here we're using the large face against that actual edge. So we're not actually back dragging our tool where we could cause tool deflection and chatter and issues. We're using that, whatever angle your tool is. In this case, it's probably like a 5 or a 7 degree relief here against the actual material we're cutting. So again, as if I slow this down a little bit and hit play, you'll see it feeds out. And then again, we're going to do a rapid move to our inside diameter. So now that we've got our inside boring all done, we've pre-drilled, now we can go back and we can actually start our milling. So I'm going to turn off my actual section view over here in the Analyze button. Now let's do our milling. So I'm going to switch to the Milling tab. I am going to do this with a 3D adaptive clearing. You guys could also use, or not a 3D, I apologize, a 2D adaptive clearing. You could also use 2D Pocket depending on the torque and the specs of your machine. But I'm now going to define my chain that I want to cut. So as you can see, is I can pick that lower chain. And one of the things that did happen is I wasn't able to grab all of those ears. So I'm actually going to use the lower part of the chain on the upper actual chamfer side. From here, we could go ahead and kick on rest machining, but as you're going to notice, rest machining does not have the ability to recognize what has already been cut. Now, a quick trick for this is to use stock contour in 2D. And what I could do is I could define that based on a diameter that's known inside of Fusion 360. So we've already OD turned those fins. So I'm going to use that selection to create my contour chain for my stock. Again, we pick that upper chain based on our part profile. So what we are going to have to do is we're going to have to set our heights tab. And I'm actually going to change this now to a selected depth because we need to machine down past that part profile. And I am going to compensate that a little bit past, again, just making everything hopefully look nice and pretty based on our profiles. So once we get everything defined, and if you're in a rush like I am, as always, I have the ability to always be prompted by Fusion to tell me, you're missing this, you're missing that. So in this case, it's telling me I'm missing my end mill that I want to rough with, and now you're seeing me define that. But now that I've defined that tool, it's going to go in and create that profile for the roughing of those pockets. Just like we did in our lathe turning, let's go ahead and do a derive once again. And the idea of derive here is just going to be a 2D contour. And as you're going to see now, we're running around the outside of our part, cleaning up all those edges. We are making a lot of rapid changes and retracts here. And the reason for that is because we are getting some interference from stock contours. So again, I always like to stress to people, sometimes that stock contour is a benefit when you're roughing. It is not a benefit when you're actually doing like finishing strategies. So again, now we've roughed around the outside and everything. Let's go ahead and punch some holes in this. I believe these hole sizes, let's go ahead and get our drilling program up, our 375. I'm going to hit those all with a spot drill first and foremost. So let's go ahead and see what we have for a spot drill. I'm going to go into my default library, and I think there is a 1/2 inch one in here. There we go. Doing some aluminum drilling. Again, my geometry is going to be based off all of these chamfers. So I'm going to go ahead and pick that chamfer. I'm going to say pick that same size hole all the way around. And now we're doing our spot drilling for our actual drilling. Before we do our true drilling through this part profile, I'm going to go ahead and bust those chamfers everywhere. And I'm going to do that with a 2D contour. And the reason why I'm doing this with a 2D contour is because these are modeled chamfers. And when you have modeled chamfers and you're using an actual spot drill tool, you will get an extra option called chamfer. Now, keep in mind, by picking the lower edge of these profiles, I don't need a chamfer width. What I do always want to do, though, is I want to offset this, by 30 or 40 thou to get the tool down and away from the profile that it's doing. And if you guys look here from the side, you can see that based on that mitered 45, we are down and away, kind of like I said, and we're automatically compensated outwards in our X with that profile. So now that we've broke all those edges, let's go ahead and knock those 375 holes into this part. Again, we're going to go back out to our default library. We're picking a drilling tool, and we're going to go ahead and speed wheel down to 375. Again, this is aluminum, so we're picking our appropriate speeds and feeds. Pick my first hole. Again, we want to make sure that you're auto merging these in the event that you don't have a spot drill. And we're also automatically picking all the other holes. So again, as we want to make sure that we're not causing a collision when we get to our first point of induction. Again, moving over to our heights tab, drill tip through bottom. As you guys probably are going to guess, we're going to go with 50 here. And now we have kind of wrapped up everything on the end of this part. To kind of verify that, we're going to go ahead and I'm just going to take a step back and only simulate everything up to when we did our ID boring. So I'm just highlighting all those with the shift and first click, last click. And then from here, we could go ahead and hit play in our simulation. We are going to turn on stop on collision just in case. But as you guys are seeing, we're not really getting any collisions. And just like that, we've finished up this flange at the end of our part. So now let's go ahead and switch down to the other end. So we're going to go ahead and restart everything. We're going to create our brand new setup. Again, I'm going to go to the turning tab first. If you fail to do so, don't worry, guys. You could actually select turning or mill turn here. From here, we're going to leave it in the primary spindle. It's not going to be a big deal for me. In this case, I'm actually going to go off model back as if we're using a stop or have a fixed point of reference. From here, if we flip over to our stock side, we're going to bring our preceding stock through. And what that means is with the rest machining, anything that we've done up to this point will automatically transfer from one side to the other. So from here, we have a lot of options to do. We are going to need to do our standard kind of lathe work of drilling, boring, and facing. So let's go ahead and get that knocked out before anything. What I'm actually going to do is I'm going to, say the least, kind of cheat the system here, is I am going to snatch up the couple of toolpaths that I want to work with going back the other way. And what I'm going to do here is because we've defined certain locations in our part. Oh, I apologize there. I don't want to post. I want to copy, but we have defined reference points in our part profiles. So by copying those and pasting those into our second setup and regenerating them, what's going to happen is our Z is a different orientation, which means it's going to flip everything back the other way for us. Now, this copy and paste may or may not work based on the tooling in your machine. So I always warn people, if you have a right hand next to a left hand with your main and your sub, this may not work out the best for you again, but it's very easy to change tools, right? Now, we're staying in the main spindle, so a lot of what we're trying to do here is going to actually work automatically for us. Let's go ahead and split this in half, and for demonstration purposes, I'll just spin this around. Again, we're going to a certain location and a certain distance past. There is a little bit of wasted cycle time here, so we could change that if we wanted to. Our boring, as you're seeing, is actually stopping here. So it is coming in. I apologize. There's a quick click here. So again, we're coming in, we're boring out and roughing out that inside diameter. And then lastly, we're doing a no dragging finishing profile inside of there too. So as you can see, it was relatively quick to get to the point where we are actually completing everything out on the back side with using those toolpaths from the front side. So let's run that through a simulation here real quick. Here comes our tool in. We did our drag across our part and back out. All right, so now that we've gotten to this point, let's start to look at the milling of our part. So what I'm actually going to do is I'm going to go down and I'm going to turn on my in-process stock. This will help us a ton with understanding what's kind of left to do. So as you can see, we have this big gigantic lug on the backside of our part. Now you notice I didn't actually do any of the OD turning for this side of the part other than the face itself. And the reason for that is we're going to come in with an end mill and we're basically going to rough everything out, right? So I'm going to go ahead and go into my milling side. I'm going to go for a 2D pocket. In this case, I'm using 2D pocket because maybe the tool doesn't have or the machine doesn't have enough torque or RPMs. Again, you could use pocket or adaptive clearing. I'm going to go ahead and select my edges that I want to machine based off. As you're going to see here is I'm actually using that edge right below the chamfer all the way around. I need to go ahead and define my bottom location. So again, as we're going to do a selection for the bottom. And now one thing I do like about using pocket clearing in this scenario is the fact that I'm actually going to take this all the way down to 0. And I'm going to use this pocket clearing strategy to also clean up my floors based on these profiles. So with that being said, one other thing we may want to do is turn on multiple depths. We could go ahead and do depths at 5 or 50. That'll be more than adequate. And now at this point, you can see it's a lot of passes and a lot of time. Now we are getting some extra stuff, like we're starting from stock top. So let's go ahead and trigger that. So we need to start from model top, not stock top. But as you're seeing, we are fully getting in there and blasting out anything and everything based on what we're doing. Now, this is a relatively long cycle. It's 22 minutes. Now, we could save a lot more time. And again, I'm just going to go in and I'm going to grab that turning profile rough from our first operation. And we're going to go ahead and post this into the second area. And I'm just going to do a little bit of organization, meaning putting this up a little higher. And now you're going to see, based on how Fusion thinks of a spun profile, we could actually knock a lot of this out with this tool long before we actually get to our actual facing cycle or creating our roughing profile inside of Fusion. Now, this is where one thing is going to change. So this is going to be the biggest difference between 2D and 3D when we talk about roughing. If I do a 3D roughing strategy and I do rest machining, it's going to help me a ton with being able to calculate where the stock is and where the stock isn't, right? So that being said, I'm going to go ahead and define this tool kind of the same way, right? So again, we did multiple depths, so we have a maximum step down of 50. I'm going to go ahead and select a bottom height. We're only going down to this flange height. We're going to start from model top. In this case, I'm going to actually leave that model top selection alone because we are doing this with rest machining. And rest machining, as well as 3D, is very much model aware when it comes to roughing out this part. So as you can see, what we got is a little weird out the start. And the reason why it is weird is because we actually failed to put this toolpath in front of that initial 2D pocket clearing that we did. So what I'm going to do is I'm going to go ahead and reorganize my stuff, and then I'm going to delete that 2D pocket just to get it out of the way so that we don't have to deal with that anymore. So again, let's go ahead and regenerate this one more time. And as you're going to see, we're now going to be roughing basically the entire top area of this part. Now, there is a couple of other settings that I do need to change based on what we're going to get here with our results. Due to my milling mindset, I always like to look at my milling toolpaths more vertical. This is going to take a little bit to calculate because it is looking back and referencing everything we've done to this point. And as you're seeing now, it has dramatically reduced the amount of area and the amount of things that we need to actually machine out. Now, that being said, what I am going to do, though, is as you're seeing, we're still starting a little high on our part. I'm going to go back into that toolpath, and I'm going to go ahead and say my heights are going to start from model top. From there, I can also actually turn off my machining boundary. We don't actually need a machining boundary based on this part profile. So we're going to go ahead and let that run once again. And as you can see now, we have a much cleaner and a much nicer toolpath profile based on that rest machining. So again, we are doing some stuff on the inside. If I wanted to, I could actually patch over this. Let's go ahead and do it just to show you guys the example. If I go back to design, I'm going to go ahead and say patch. Again, I can add a patch over that hole, jumping right back to manufacture in this case. And then in my toolpath, what I need to do is I need to go into my geometry. I need to add model. So I'm going to toggle this on and pick that patch. And then I'm also still going to include my setup model as well. In the meantime, while that loads, I'm going to go ahead and turn that patch back off so that we don't have it in the way for anything else we have going on. Nice thing about Fusion is the way it calculates in the background of your computer. You could still work very efficiently. However, for my demonstration purposes, I always like to wait and give you guys the results as we go. And just like that, that inside pocket area is now gone. So from here, if I wanted to, we could switch that tool out. We do need to actually put a little bit of a fillet around this bottom. So in the case of this fillet, I know it's 060. So we're going to go ahead and when we do our outside profile here, we're going to go ahead and grab that 060. Before I do that, however, I am going to keep this flat end mill. And the reason for that is because I'm going to do this edge, which is square, with my edge of my flat end mill. So again, as we are using a 1/2 inch just standard flat, If you wanted to turn on multiple passes, by all means you can. But what I'm showing you here is the ability to come in and come across that part and clean up all of those chamfers on the two ends in one shot. Notice how, because of the continuous rest machining, we did forget that we do still have stock to leave on the bottom of that pocket toolpath. So we would also want to turn that off as well. Now, with that being said, we go back to our 2D contour. When it comes to selecting chains with fillets on the bottom of them, in the case of this 2D profile here, I always like to pick the upper edge of the actual profile. And as you're seeing is I have to pick all of those edges, including that one little gap that's getting me. And then I do need to manually set my depth, right? So again, as we're going to go to a selected depth, again, we're going to swap our tool out. Let's go back to the Fusion 360 library. We're going to grab our bowl end mill. Again, this bowl end mill technically has a 15 thou radius. So if we see a little bit of a collision, you guys know I could change this out, but I'm just trying to get through this to give you guys an idea of what to expect when using Fusion and how it's going to work in these scenarios. So just like that, we've now defined that contour profile outside of our part. I am actually going to turn off display in process stock just so that we can keep moving forward. Now, as always, we've gotten to this point. We've knocked out a bunch of things. We could actually go in, and if you guys remember when we did our actual spot drill chamfering toolpath, again, I'm going to just push Control Copy, Control V based on my new setup, and redefine some of these profile chains. So again, we're going to go in and pick the edges that we want. We're going to go ahead with that lower edge on both of these faces. And just like that, we're now going in and we're actually knocking that edge off of everything. So let's flip to the side now and let's work inwards through this like electronic or sensor enclosure area based on our part profile. So again, it's up to you. I really am going to just go for a 2D adaptive clearing here. Now, the big difference that we're going to do here is we're actually going to set tool orientation, and I'm going to pick the bottom floor. And as you're going to see, my Z is now orientated to that face. Keep in mind, based on your machine, you do have to be self-conscious about your X and your Y. However, those could be defined off edges and faces as well. Now, my pocket that we want to machine is right here. Our heights tab, we're actually going to start from a selected height because everything has been done down to this flat. And just like that, we can go in and we can actually rough out that pocket. Again, if you wanted to, you could set that to 0. We could do our derive now. I'm going to go in, say derive. We're going to go into a 2D contour. And again, there's our 2D contour to clean up the floor of our pocket. From here, let's go ahead and knock out our spot drilling. And we could also do that chamfer. So what I'm going to do here is we're going to go in. We're going to grab that 1/2-inch spot drill that we've been working with. I am going to do tool orientation once again using my Z. And then let's define our edges. So I'm actually going to pick based on this face right here. And I'm going to say select same size diameter. And then I'm also going to do this face down here. And what you guys are going to notice, oh, we don't need containment. We need the actual face. Is one, that spot drill is way too big to achieve this. And I may need to split this up twice or use a couple of different tools. You, again, can go back, redefine your tools. I'm just giving you the process and the order of operations to be able to achieve what you're seeing me do here. So from here, again, we're going to go in, we're going to do our drilling now. Those holes are based on, let's go ahead and get our tool orientation first. And then if we put our mouse on that hole, it's a 1/8-inch hole. So let's go back into our default library, grab our drill bit, and we're going to go ahead and speed wheel down to the 125. Aluminum, and again, we define our hole, all the same size, things of that nature, right? So as you're seeing is I'm wrapping this up relatively quickly. I guess the one thing I didn't do is let's go ahead and do that 2D contour for our chamfer. We're gonna go ahead and go back to that spot drill. So I would have to have one horizontally and vertically mounted inside my machine to be able to do this. But as you're seeing is, again, is it's the same process over and over. And I think a lot of people fail to think that way, that it is relatively simple to come into Fusion 360 with little to no experience and use the easiest of toolpaths to create some of the most complex parts. Before I let you guys go, as always, I got to tell you, Don't forget that it's not what you know, it's who you know. And if you guys have any problems or any issues whatsoever, feel free to reach out to me with the link down below. I'm here to assist in any way possible. Everything from custom training to post-processor edits and even selling you the software. And not to say that I need you guys to buy software through me. However, purchasing software through me does support this channel and continue to make it grow and be able to do this all day, every day for each and every one of you. So with that being said, don't forget to like, follow, and subscribe, and have a great rest of your day.